Alrighty, we're solving trig equations in this video. So by this, I mean we have things like this. Solve for sine of x equals a half, and then you're given a certain range of x values. So depending on your favorite method, well, most people will start by just doing inverse sine. And you could absolutely work it out. So go onto your calculator, make sure you're in radians, because we're measuring in radians here. And we can literally just go inverse sine of a half, and it'll either tell you directly that it's just pi over 6, or if it gives you a decimal approximation, you can just confirm that that's pi over 6. And that's one answer. But we want all the possible answers. So I'm not too keen on using inverse sine notation because there are actually multiple different answers, and inverse sine only gives you one of them. So we're going to be looking for all the possible values that if we plug that value into sine, we get a half. Now, I can tell you that one value is pi over 6, as we just found. So if we check and go sine of pi over 6, we should get a half. But I can tell you another value is sine of 5 pi over 6. And if we check this, we should also get a half. Now, there's a couple ways you can get this. First way is you should just have a unit circle on you, which will be very helpful. And we're looking for sine equaling a half. So that would be this angle at pi over 6, or this angle at 5 pi over 6. And that's pretty much everything I can find. The other way that you can do it is you can get your one value here from inverse sine. So pi over 6 is what inverse sine spits out for a half. And then you can sort of just think about, okay, if this is the unit circle, where's the other point that has that same height? Excuse my drawing, but it's across there. We know that the full angle there would be pi. And so this remaining angle, just this green one there, would be pi take pi over 6, which is 5 pi over 6. Okay, so at any rate, that's how you get those two angles. There's a few different ways you can use, pick your favorite. But then we actually haven't solved this question fully, because it's 0 to x up to 3 pi. So we're actually missing one of the angles, or maybe even two of the angles. So the two angles that we've got are pi over 6 and 5 pi over 6. And I might just draw this angle in first. The other angle that we can sort of consider is if we go all the way around the unit circle from the start, and then another pi over 6, right? And then we would end up back at this point again. So what this angle would be here is one full loop, 2 pi, plus pi over 6. And you can think of that as like 12 pi over 6 plus pi over 6. But at any rate, you get 13 pi over 6. So that's another answer we've got to add onto our list here. And believe it or not, there's yet one more answer here as well. So the other answer that I could get is if I took that angle that we also had, 5 pi over 6, and I went a full loop around and then 5 pi over 6 again, that would be 2 pi as a full loop and another 5 pi over 6. And if you work that out, you get 17 pi over 6. So that is our other angle there, 17 pi over 6, and that's the full list of x values. Okay, so that's what we got. And just to verify, if I do go 13 pi over 6 into sine, I should get a half as well. And same as if I go for 17 pi over 6. Okay, now that's how you're sort of intended to solve the problem. Now I'm going to show you a little cheat method that works really easily. Well, it works to check that you got the right answer at least. So if I graph both things, if I look at sine of x here, and I also graph 1 out of 2, or a half, and I set my window to what they've said, so 0 to 3 pi, we will see a few things. So we're going to see 4 things to be exact, 4 intersection points. Now you still have to do the full process, because if you try and do intersect on your graph, it won't give you the pi over 6 version. It'll just give you 0.523, which is pi over 6. But my whole purpose for graphing this is, hey, you can actually see that you're looking for 4 answers here. And whenever you've got 2 answers that you're starting with, the way that you get the next 2 is you just add on a full loop around the circle each time. And similar there, you can add on 2 pi. Now, if we wanted our next number in the list, we would take 13 pi over 6 and we would add on 2 pi to that. And I reckon that gives us 25 pi over 6. But we don't keep that one because that is too big. That is bigger than 3 pi. But if we extended out our window further, we would see that as another answer as well. Okay, let's approach it with this one. Sine of 2x is minus root 3 over 2. And let's see if we can do everything that we did before. So the thing inside the sine should evaluate to minus root 3 over 2. There's a couple ways you can get that, but I'm just going to pull it straight off the unit circle. So minus root 3 over 2, I'm seeing that and that. So 4 pi over 3 and 5 pi over 3 are the angles I'm interested in. So 4 pi over 3 and 5 pi over 3. So that should be 2x equals all that. And then you would just solve this like a normal equation. So realistically, I would like to divide by 2. So I've got x equals 4 pi over 6 or 5 pi over 6. I guess you could simplify that to 2 pi over 3 if you want, but I'm not going to bother. Okay, cool. And, well, we did these in the range 0 to 2 pi. So surely we've got all the answers we want. Absolutely. Let's check. So let's see if we can go sine of 2x. And I'm expecting to see 2 answers here. And equals minus root 3 over 2. We would hope that we get those same 2 answers. I better set up my window to go from 0 to 2 pi. And let's see how it's gone. Uh-oh, there's 4 answers. It's almost like I planned it. So what went wrong? Well, this is what went wrong. Yes, x goes from 0 to 2 pi. And if I try and get my next answer across here by adding on 2 pi, I would get, let's see, 2 pi is the same as 6 pi over 3, if you want. So that would be 10 pi over 3. Now, normally what we'd sort of do is say like, oh, well, that's too big. But when we do this next step and we divide by 2, what you get is 10 pi over 6, which all of a sudden is not too big. That's less than 2 pi. So we actually do keep this point 10 pi over 3. And not only that, but we need to also add on 2 pi to that point there, 5 pi over 3. And I reckon that's going to give us 11 pi over 3. Once we divide this by 2, that's going to give me another answer at 11 pi over 6. Now, the reason that this range stuff worked out a bit weird is because it's 2x in the brackets there. So if we're looking for 0 to x to 2 pi, what that actually means is we can multiply everything by 2. So 2x is in between 0 times 2 and 4 pi. So we actually have to go all the way out to 4 pi on our original list. Now, my advice is just write out a bunch of numbers. So for example, your next one would be 10 pi over 3 plus 2 pi. So that would be 16 pi over 3. And then if you do the next step and halve that, so that's 16 pi over 6, we can actually get rid of that one because it's too big. Similarly, you can go left on your list as well, which we'll see in this example here. Okay, but I'm hoping you can see that actually graphing it tells us that there should be all 4 solutions. And if we want to just check, we could check all 4. But if I just go trace and I type 10 pi over 6, what that should do is highlight the third intersection point. Yes, it does. So that's good. Okay, solving this equation. So what we've got to do first is rearrange it. So I'm going to divide by 6. So 10 of 2 brackets x plus pi over 8 is 2 root 3 all over 6. So in other words, we can just simplify that down to 10 of 2 brackets x plus pi over 8 is, now that all simplifies down to root 3 over 3. And I think that's one of our options on the unit circle for 10. Indeed it is. So there's 2 points where that happens. So root 3 over 3 happens here at pi over 6, and it happens here at 7 pi over 6. Okay, so the stuff inside the 10 should all equal pi over 6 or 7 pi over 6. Just like that. Now, because the range is from minus 2 pi to 2 pi, what I usually do, so 2 brackets x plus pi over 8 equals, I usually just go left and right a whole bunch until I've got enough that I'm confident, and then I'll start rearranging. So I could go pi over 6 and add 2 pi to that. So that would give me, well, 2 pi is 12 pi over 6. So that would give me 13 pi over 6. And if I took 7 pi over 6 and added 2 pi to that, so that's like adding on 12 pi over 6. I've got 7 plus 12, which is 19 pi over 6. Now, we've actually got to go backwards as well. So I might go backwards from, get rid of all this. Let's go backwards from 7 pi over 6. So we're going to be taking away 2 pi. 7 take 12 is minus 5 pi over 6. And then we're going to go backwards from pi over 6. And we're going to get minus 11 pi over 6. And I might just get a couple more points here, just because I'm not exactly sure how many we're going to need. So let's go forward from 13. You might also notice that every time I'm doing them in groups of 2 and sending each pair of 2 forward. Because the unit circle has 2 spots, but then each spot needs to go around another loop. So 13 plus 2 pi, that would be 13 plus 12 pi over 6. So that would give you 25 pi over 6. And then we can keep going out further. So 19 pi over 6 plus 2 pi for our next one. If we do that, 19 plus 12 is 31. Okay. Next, we got to go back. So I've probably got way too many points, but we'll see how we go. So if we go back here, minus 5 pi, take another 12, so that would be minus 17 pi over 6. And lucky last, minus 11, take another 12, would be minus 23 pi over 6. Okay, now we've got to divide both sides by 2 to get rid of this 2 here. So what I'm going to be left with is x plus pi over 8. Now to divide all these fractions by 2, I can literally just change the denominators to 12 instead of 6. Okay, 25 pi over 12 and 31 pi over 12. Okay, last step, we need to subtract off pi over 8 from each side. Now there's a whole range of ways you can do this. So if we look at this first term, for example, 23 pi over 12, take off pi over 8, we'd need a common denominator. So I think 24 is going to be our best one. So that would be 46 pi over 24. So double the first fraction and triple the last fraction. So that would be 3 pi over 24. And so 46 take 3 is, oh, my apologies, that's negative. So that would be minus 49 pi over 24 for our first term. But realistically, what you're probably going to do instead is just go into a calculator. And we're going to go, you don't even need the pi's in there, but I'm going to do it just for completeness. 23 pi over 12, take, and then we got pi over 8, minus 49 pi over 24. Okay, now I'm not going to sit here and make you watch me do all of these, but essentially what I'll be doing for the next ones are minus 17. So that second one would be minus 37 pi over 24. All right, so I've chucked all those into the calculator and I've got this big long list of answers. Now, most of these answers are good. If I look at something like, let's go 35 pi over 24, for example. So 35 pi over 24. we get that number. And that is less than the range we wanted, which was up to 2 pi. And 2 pi is about 6.28. So yes, we would keep something like 35 pi over 24 because that's in the range. And probably the easiest way to tell is you can actually write both these as fractions over 24. So that one would be 48 pi over 24. And that one would be minus 48 pi over 24. So if we look at our list again, we can see that we keep almost all these. The one on the very left we actually get rid of. That's too big. And just cross it out that way so we can see what the number was. And then 47 pi over 24 we keep. It's just barely small enough. But 59 pi over 24 we would get rid of because it's too big. So this is our complete list of answers. And we should see 1, 2, 3, 4, 5, 6, 7, 8 intersection points if we graph our original function and 2 root 3. So we'll just give that a quick go. Clear out that old one. So what do we have? 6 tan of 2 brackets x plus pi over 8. And 2 root 3. Draw that. And we better set our window from minus 2 pi up to 2 pi. And I think I said I was expecting 8 intersection points, I reckon. 1, 2, 3, 4, 5, 6, 7, 8. And if I go to the 7th one in my list, which was 35 pi over 24, and I just trace that number, 35 pi over 24, I would expect it to highlight my second to last intersection point in this window. And it does, so that's a relief.